Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Guys, today we're going to continue solving quadratic functions, and we're going to learn another skill. So far, we know how to solve quadratic functions by factoring and using the zero product property, by square rooting, okay, by using substitution and then factoring, little U method there. We learned completing the square, and now we're going to learn the Mac Daddy of all of them, okay? This formula can be used to solve any quadratic function. Does not matter how ugly or pretty it is. If you don't want to complete the square, fine, go ahead and use this. You don't want to use the square root method, fine, you can go ahead and use this. You don't want to factor, fine, go ahead and use this. One little caveat, one warning. If it's in quadratic form, okay, where we have to substitute with a u, you cannot use this for solving x. You can use this for solving the u part, but you got to plug it back in to find x. So many of my students say, Mr. Morrow, if this can be used for everything, why would you torture us with all the other skills? Because believe it or not, guys, just because this can solve any kind of quadratic function does not mean that it is the best or most efficient one to use all the time. I can factor a lot quicker than I can use this. Sometimes if you have even numbers, I can complete the square quicker than I can use this. Okay, so for me, I use this when it's not factorable and it's real ugly and I just want to get to the answer. I don't want to complete the square. All right? But you can use the quadratic formula to solve any quadratic function. Another super powerful thing about the quadratic function is you can use a part of it called the discriminant to determine how many functions and what kind, solutions, how many and of what kind, what type of solutions you're going to have. So for example, or not example, let me show you the formula. One can solve any quadratic equation in standard form, ax squared plus bx plus c equals 0, by using the quadratic formula, where x, which remember that's what I'm trying to solve for, right? When I'm solving for a quadratic function, I'm solving for x. I want to find the points through which the graph intersects the x-axis. I want to know, boom, boom, those are my solutions. That's what I'm trying to find when I solve. And the formula I'm going to use is negative b plus or minus square root of b squared minus 4 times a times c divided by 2a. That's a quadratic formula, guys. All right? Now, let's do it. What do you mean, Moro? There's nothing else to do? No, that's it. What's the first thing that you got to put in standard form? Yes, sir. You have a question? Yes, sir. So, my brother, thank you. Yeah. No. No. Don't separate this plus or minus to the end. No, do not do this either. B squared and then minus. No, do not do that. No, keep it the way it is. Thank you, sir. Yeah, guys, please, it's such a great question. Please don't try to manipulate the quadratic formula, guys. It has been proven. It works. Trust me. Okay? All right. So first off, you got to write, anytime you're solving a quadratic function, you got to write in standard form. So it's just 2x squared minus x minus 4 equals 0. Now, I recognize these because I've been doing this for a long time. I would suggest that you label your a, your b, your c. A is the coefficient of x squared, so a equals 2. B is the coefficient of x, so b equals negative 1. And c is the constant, so c equals negative 4. And now, let's plug it into the formula. Negative b plus or minus square root of b, notice how I put it in parentheses, squared minus 4 times a times c all over 2a. So everyone see that? So this is going to be 1 plus or minus square root of 1 plus 32 is 33 over 4. I cannot simplify that any further, and I am done. My solutions are 1 plus or minus square root of 33 over 4. What does that mean? That means that I have the solution 1 plus square root of 33 over 4, comma, 1 minus square root of 33 over 4. Those are my solutions. I do not have to separate them into the plus or minus because the plus or minus is right here. Now, sometimes I'm going to have number values that I can actually calculate. For example, I may have 1 plus or minus 12 over 6, for example. If that's the case, then I want the values. 1 plus 12 would be 13 over 6. 1 minus 12 would be negative 11 over 6. This is nothing to do with what we just did, but I'm just letting you know that sometimes if you have an actual value, I need to actually figure it out. I need to find it. Okay, next. I got x squared plus 4x equals negative 4. First, I'm going to create a trinomial. So x squared plus 4x plus 4 equals 0. Okay. Even though this is factorable, I want to use a quadratic function. So I'm going to go negative b plus or minus square root of b squared. Please put that b in parentheses. Minus 4 times a times c over 2 times a. This is going to be negative 4 plus or minus the square root of 0 over 2. Oh, so look at that. X equals negative 2. Does that make sense? Yes, sir, my brother. Because it was negative b, and it was a negative 1 times just positive 4, and negative 1 times 4 is 4. I put it over here because a negative times a negative. Okay? Yes, sir. Yes, if this was a real test, and it just said solve, and I had this, me personally, I'm going to recognize the perfect square, and I factor it. But I just want them to see what happens when you get a 0 in the radical, right? Square root of 0 is 0. I don't want you to flip out. All right? Next, it's already in standard form. And again, I can factor this. This is factorable. But I want you guys to practice the quadratic formula. So negative b plus or minus b squared minus 4 times a times c over 2 times a. So negative 6 plus or minus 36 minus 36. Hey, 0 again. So x equals negative 3. For d, this is not factorable. So I've got negative b plus or minus square root of b squared minus 4 times a times c over 2 times a. And then this is going to give me negative, oh, sorry about that. Negative 4 plus or minus the square root of 16 plus 12 is 28 over 2. I'm not done. I can simplify this. This will become negative 4 plus or minus. What's the square root of 28 turn into, boys? 7 times 4, which is, so that's 2 square root of 7. Good job, guys. Over 2. And then this 2 can be divided to this and to this. What's happening here is this is really negative 4 over 2 plus or minus 2 square root of 7 over 2. So I can reduce this to negative 2 plus or minus square root of 7. Does that make sense, guys? Talk to me, please. Yes, sir, my brother. Of course I can, son. Thank you for your honesty, as always, my brother. Thank you, thank you, thank you. All right. So from here, we're going to go ahead And we got negative 4 plus or minus 2 square root of 7 over 2. Because 28 is 4 times 7. Square root of 4 is 2. Is that you with me so far, my men? Okay. Remember that this denominator down here gets divided to this and to this. But sometimes you can't visualize that, so separate it. So this negative 4 is being divided by the 2, and the plus or minus 2 square root of 7 is being divided by the 2. So that will equal negative 2 plus or minus square root of 7. That is in the simplified form, my brothers. Does that make sense, kid? Any questions on that, guys? At all? Okay. All right. Now, the discriminant. What is so special about the discriminant? Well, the discriminant is really important. Okay. The discriminant of a quadratic function lets you know how many and of what type of solutions you're going to have. It lets you know how many and of what type of solution you're going to have. And the discriminant is the actual b squared minus 4ac. You don't have to use a square root. You don't have to use the whole rest of the formula. You don't have to do any of that. All it is b squared minus 4ac. And now here, hopefully, you'll see some visuals that will hopefully start making you see connections that I've been trying to make before. If you have b squared minus 4ac equals 0, guys, okay, if it equals 0, you have one solution. It's a perfect square. You have one solution. That means it hits at one point. Do you see how it hits right there, guys? Remember, I've been repeating like crazy. That's my solution. That's the x-intercept, right? If b over 2 is greater than 0, if it is positive, that means I have two real roots or two real solutions, hence right here and right here. Don't worry about if it's facing up or down, but to answer your question, the a here is positive, that goes up. When the a is negative, it goes down. Thank you so much, sir. If b squared minus 4ac is less than 0, guys, if it's a negative, then there's no real solutions, but there are complex solutions. So you will have no real solutions, but you will have two complex solutions. We already know about I, so that will work, okay? So, yes, sir. Well, look at the graph right here. Is it touching the x-axis? That's how you know that you have imaginary solutions. You plot your points like normal. You just won't have any points going through the x-axis. See, none of these points here touch the x-axis. So that's why they're called complex solutions. They're not real because they don't hit the x-axis. If they hit the x-axis, they'd be real solutions. If they don't hit the x-axis, that means they're imaginary. You're still going to have solutions. They're just complex or imaginary solutions, sir. Yes, sir, my brother.
If you got the two imaginary solutions, just try to figure instead of so then you just plot the points, it would go anywhere. Would it be a y-intercept?
No, there would be a y-intercept. The y-intercept will be right here. You still have a vertex. Everything in the graph will be the same, except there's no real solution. That means it never hit the x-axis. And don't worry about this one, guys. The if it's a perfect square, the easy root, don't worry about that. If it's positive, you have two real solutions. If the discriminant is negative, you have complex solutions. If it equals 0, you have one solution. Now, what is the purpose of this? The purpose of this is to see if you can continue, if you go on, and also to give yourself an idea. Sometimes they will just ask you, I've seen this on the SAT, what is the number of real solutions for each equation? Okay, I'm going to go b squared minus 4 times a times c. This is 9 minus 56. That's going to be a negative 47. These are no real solutions. Done. No real solutions. I have complex solutions, but no real solutions. Why, Moro? Because if the discriminant is less than 0, you do not have any real solutions. For B, first put it into quadratic form, standard form. Okay, now I want to check how many solutions this has, if any real solutions. So B squared minus 4 times A times C. That's positive 36 plus 20. Yeah, that's 56. So I've got 2 real solutions. That's the beauty of the discriminant. Yes, sir?
The SAT and Petty wrote, what is the number of solutions in each equation, not real solutions?
Then,
For two, correct?
if they had said what are the number of solutions, you would have put 2 complex. Yes, sir. Solutions. Very good. But here, exactly like you said, thank you for reading. We were just asking for real. But it just said any solution, yes, for sure. Okay? And then last but not least, something like this, guys, don't be afraid. You would be able to use a calculator. The revenue received by a company selling X specialty t-shirts per week is given by the function R of X equals negative 0.005 X squared plus 30X. How many t-shirts must be sold in order for the revenue to be $25,000 per week? For any of you guys, excuse me, or ladies out there watching this on the internet that ever want to do a business, guys, this is what you have to do. You want to know, when will my R of X, I love it when it does that. I love it when it does it again. One more time, there we go. When is my R of X going to be 25,000? So for A, guys, when will 25,000 equal negative 0.005 X squared plus 30X? I'll go ahead and finish this, but I will tell you what I'm going to do. I'm going to make a quadratic function. I'm going to make a standard form, and I'm going to plug it into my quadratic formula. Please go ahead and leave quietly while I do this. Thank you very much. Have a great day, and I hope you learned a lot. So, we're going to go ahead and make a quadratic function here in standard form. So I'm going to subtract 25,000 to both sides. So I'm going to get 0 equals negative 0.005 X squared plus 30X minus 25,000. I'm definitely not even going to try to factor that or complete the square. That's the beauty of the quadratic formula. When it's nasty like this, that's when I use it. So I'm going to go negative B plus or minus square root of B squared minus 4 times A times C over 2 times A. So this is going to give me negative 30 plus or minus, if I got 30 squared minus parentheses 4 times negative 0.005 times negative 25,000. That will equal 400 over 2 times negative 0.005. That will equal negative 0.025. Then from here, we have negative 30 plus or minus 20 over negative 0.025. And then we have to actually calculate. So negative 30 plus 20 is negative 10. And negative 10 divided by negative 0.025 is 400. And negative 30 minus 20, that's negative 50, divided by negative 0.025, that equals 2,000. So you will make the revenue of 25,000 after you have sold 400 and 2,000 units. Now, let me explain why this occurs. This occurs this way, guys, because when you look at a parabola, okay, what's happening here is this. You're getting to this 25,000 mark here and here. So at this X, it's apparently after 400 sales. And then at this X, it's apparently after 2,000 sales. Okay? Now for you guys, I want you to do this last one at home, number 4. And yes, I know you're at lunch, and I hope you're watching because I'm going to check tomorrow in class. Have a great day. God bless you. Thank you, and I hope you learned a lot. Bye-bye, my friends.